All right, Algebra, starting chapter 11 today, and it's all about radicals, okay? So talking about 11.1, squaring or expressing roots. So first thing we're going to do is we're going to talk about a definition here. A square root is one of a number's two equal factors. The symbol for a square root is the radical sign, which looks like that, okay? The expression underneath the radical sign is called the radicand, okay? The radical sign always indicates the positive square root, which is called the principal root. If you need a negative square root, a negative sign is placed in front of the radical, okay? So the square root of 9, if the principal root would be 3. This negative square root of 9 would be negative 3, okay? So example number 1, super straightforward. What's the square root of 4? It's 2, okay? What's the negative square root of 16? Negative 4, okay? Sometimes we use other roots, okay? We have a cube root, which is one of a number's 3 equal factors, and we can also have an nth root, which is one of a number's n equal factors. So example number 2 is what is the cube root of 125? So what do we multiply by itself 3 times to get 5? 5 cubed is 125. So the cube root of 125 is 5, okay? What is the fourth root of 81? What do we multiply by itself 4 times to get to 81? That would be 3 to the fourth is 81. So the fourth root of 81 is 3. The even root of a negative number is not a real number. However, the odd root of a negative number is a negative real number. So example number 3 says, what is the square root of negative 4? Based on this rule right here, this is not a real number, because this would be an even root. Square root, that would be 2, right? And that's an even number. Even root of a negative number is not a real number, okay? B, what is the cube root of negative 27 over 125? We can rewrite that as the cube root, and we're going to simplify that, both 27 and 125 reduce down to 3 over 5. Oops, sorry. I did that a little wonky. Let's just talk about what's the cube root. What's the cube root of 27? The cube root of 27 is 3. What's the cube root of 125? It's 5. This is negative, and our rule up here says the odd root of a negative number is a negative number. So the cube root of negative 27 over 125 is negative 3 over 5. And then C is what is the fifth root of negative 32. So again, that's an odd root of a negative, so we know we're going to end up with a negative number. What do we multiply by itself 5 times to get 32? Negative 2 to the fifth is negative 32. So negative 2 is the fifth root of negative 32. Okay, we are skipping the estimating part. Okay, skipping the estimating part. So we're moving past example 4 and example 5. And now we're going to talk about some exponential expressions with fractions, okay? So the exponential expression of a to the x over b is equal to the b root of x to the a. B is what's called our index, and a is the power of the radicand. You can express x to the a over b like this, or you can express it like this. So here we have an example. 8 to the 2 over 3 is the cube root of 8 squared. Or you can write it like this, the cube root of 8, and that is squared. Okay, so example number 6 says convert 5 2/3 to radical form. 5 is my radicand. My index is what root it is, and that's always the denominator. So there's my index. And my numerator is always the power of the radicand. So that would be the cube root of 5 squared. And I'm going to simplify that because I know what 5 squared is. That's the cube root of 25. That is converting 5 to the 2/3 power to radical form. B says convert the 5th root of x cubed to exponential form. So x comes out. B is right here. That's my index. So that's the denominator. So that's 5. The power of the radicand is the numerator. So it's x to the 3 over 5. Example number 7. Write 3 1/2 times x to the 3 over 4 as a single radical, okay, as a single radical. So what we're going to do is we're going to convert 1/2 to a fraction over 4. So 3 1/2 is going to be 3 2/4 times x and 3/4. Why did we do that? Because we need a single radical, so we need a single root here. So the index of our root for this one, our denominator is now the same. So the index of our root is 4, and that's going to be 4 times 3 to the numerator, or excuse me, the 4th root of 3 squared times x to that numerator, x cubed. We can simplify 3 squared. So that is the 4th root of 9x cubed. Then B says convert the 4th root of 7x cubed y squared to exponential form. So that is going to be 7. Remember, 4 is the denominator, and that's just 7 to the 1 there. So 7 to the 1 over 4. X, 4 goes on the bottom, that's the index, and x is being raised to the 3, so that's the numerator. Y, 4 goes on the bottom, it's being raised to the 2nd power, so that is the numerator. So 7 1/4 times x to the 3/4 times y to the 2/4, and then I'm going to reduce 2/4 to 1/2. Okay? And now it is an exponential form. That is this lesson.